Hello everyone. Okay, now we are going to discuss more sums in relation and function. As I told you before, the question number 11 here is given as if f is a function from R to R and g is a function from R to R are defined by fx equals to x square plus 3x plus 1 and gx is 2x minus 3. Find f, o, g and gf. Now, fx is given to you as x square plus 3x plus 1 and gx is given to you as 2x minus 3. Now FOG can be written as f of gx. So the function gx is 2x minus 3, right? Now in place of x, wherever in this function fx, we have to put 2x minus 3. So this can be written as 2x minus 3 whole square plus x here, the 2x minus 3 in place of x, 2x minus 3, then plus 1. Now this you can open with the formula of a minus b whole square. So a square plus b square minus 2ab, that is 12x. This will be 6x minus 9 plus 1, right? So 4x square minus 12x plus 6x will give you minus 6x plus 9 minus 9, then plus 1 is left. So this is the value of your FOG. Now GOF of x will be written as g of fx. Now what is your function fx? X square plus 3x plus 1 and the function gx is 2x minus 3. Now in place of x you have to write whatever is there inside the bracket of g, this function g. So this can be written as 2 function g. In place of x you have to write this bracket, x square plus 3x plus 1 minus 3. So solving it out, 2x square plus 6x plus 2 minus 3. The answer will be 2x square plus 6x minus 1. So this is your GOF. Okay, now the next question is, the composite of function is associative, that is, if f, g and h are three functions such that FOG, OH and FOGOH exists, then you have to prove that FOGOH equals to FOGOH, right? Now in this case, let us just define the function as h is a function from a to b, g is a function from b to c, and f is a function from c to d, right? Now FOG, the function of this with this composite, okay, this will be from b to d. Now understand the pattern. Second function, domain of second function and the range of first function. It goes like that in a composite, right? Then h is given as from a to b. Now FOGOH, here domain of second function a and FOG is the first function from b to d, so range of this, right? It goes from a to d. Now this was your LHS, your RHS, GOH, G and H, GOH. So from A to C, right? GOH will be from A to C and F is from C to D. Now FOGOH will be from A to D. So we have already shown that FOGOH is from A to D and FOGOH is also from A to D. Now let us assume that x belongs to A, y belongs to B and z belongs to C. Okay, so such that hx equals to y, because the element of domain of h will be from A. So hx equals to y, its range will be from B, right? Now domain of g will be from B, so gy equals to z. We are only defining these two functions because we need not to define this f right now. Now f of g of h gives of x can be written as f of g of hx, right? Here hx is what? Y. So f of g of y, this will give you f of gy, which is equal to gy is what? Z, f of z. Similarly here f o g o h of x, f g o h of x you have taken into bracket, composition is gone. Now here this the symbol of o, we can write it like this in a bracket, right? Now f of g of hx, you can write it like this, right? Now what is g of hx? What is hx? F g hx is y, so gy it is. F of gy is nothing but f of z. Okay, this way we can show that f of g of h equals to f o g o h, right? Now let us do one question based on this. Okay, here the function fx is equals to 2x, gy is 3y plus 4, and hz equals to sin z. Okay, where x, y, z belongs to natural number. Now you have to show that HOGOF equals to HOGOF. This you have to show. Okay, now in this sum, first of all, you're going to write HOG of fx, right? This can be written as HOG. What is fx? Fx is 2x. This further can be written as h of g of 2x, right? In place of y, what we are going to write now? 2x. So this will be written as h of 3 into 2x plus 4, which is h 6x plus 4. What is the function of h? The function of h is sin z. Hz is sin z. So h of 6x plus 4 will be what? Sin 6x plus 4, right? This is your LHS. Now RHS, HOG OF. Okay, this can be written as HOG of fx. So HOG, what is fx? 2x. Further, h of g of 2x, right? Again, what is g? Function of g is 3y plus 4. So in place of y, what we are going to write? 2x. So 3 into 2x plus 4, which is h of 6x plus 4. No, the function of h is sin z, so it will be sin 6x plus 4. So your LHS is this and your RHS is this. They both are equal, so hence it is proved. Now we will do question number 14, which is an interesting good question. If f be a greatest integer function and g be an absolute function, then find the value of FOG of minus 3 by 2 plus GOF of 4 by 3, right? Now in this case, the function that is been defined is like this. F is greatest integer function and gx is absolute function, that is mod function, right? Now greatest integer function, how it is defined as the value of fx will be 0 if x lies between 0 and 1. Okay, whatever is the value of x between 0 and 1, whether it is 0 0.7, 0 0.85, 0 0.12, whatsoever, whatever is the value of x, the value of y, the value of fx will be 0. Similarly, it will be 1 if x lies between 1 and 2. Okay, now in this case, what we are going to prove that the greatest integer function, you have to prove that what you have to find the value of FOG of minus 3 by 2 plus GOF of 4 by 3. Right, you have to find the value of this. Now, this can be written as FOG of minus 3 by 2 can be written as f of g minus 3 by 2. G is nothing but absolute function. So, f of minus 3 by 2. Absolute function will be positive, right? So, this will be f of 3 by 2. If we write it in terms of decimals, f of 1.5. So, the value of x lies between 1 and 2. So, what will be the value of fx? Value of fx will be 1. So, here answer will be 1. Again, second part of this, GOF of 4 by 3. This will give you G f of 4 by 3. We can write 1.3. Right? This can be written as G of 1.3. If the value of x is 1.3, then value of fx will be what? 1 only. So G of 1. Right? Now G of 1, G is what? Absolute function. So we can write mod of 1, which is 1 only. Now adding these two, FOG of minus 3 by 2 plus GOF of 4 by 3. When we are going to, the value of this is 1, the value of this is 1, answer is 2. Now the next sum, question number 15. If f is a function from R to R, be defined by fx equals to 3x minus 2, and g is a function from R to R, be defined by gx equals to 3x plus 2 by 3, show that f of g is IR, that is identity function, right? This means it should be equal to x, right? Now, the function of fx is 3x minus 2 and gx is this. Okay, now FOG of x will be written as f of gx. What is gx? X plus 2 by 3. Now the function of fx is equal to 3x minus 4, and f of this will be 3. In place of x, you have to write this entire thing which is inside the bracket, x plus 2 upon 3, then minus 2. This 3 gets cancelled, which is x plus 2 minus 2. Answer is x, which is IR. So FOG equals to IR, which is an identity element. Now let us do one more sum of the type. If f is a function from R to R, be defined by fx equals to 10x plus 7. Find the function g, which also is from R to R, such that GOF equals to FOG equals to IR, that is identity function. Now let us just say FOG of x is IR. IR is nothing but IX or x. Right? Now f of gx equals to x. Now the function fx is given to you as 10x plus 7. Right? In place of x, what do we have? Gx. So we can write it as 10 gx plus 7 equals to x. Can we write it like this? So this will be 10 gx equals to x minus 7. So gx equals to x minus 7 upon 10. Now this is also the function from R to R. So we can define it, g is a function from R to R defined as gx equals to x minus 7 upon 10. I'm going to upload more videos on relation and function. I have listed around 31 sums so that you can have the revision of the entire topic of relation and function. So we have done till 16. Rest I'm going to do in my next video. So stay tuned and subscribe the channel so that you can get the notification of my next video. Thank you.